And our suicide rate isn't that high.
Alright. Here's talk about snow and suicide rates.
Rain, too.
Rain. Overcast.
I just overheard. Yeah, I got it. I started grading it, but I haven't put it up here yet, so just good. Alright, so if you guys haven't realized yet, the next test is right around the corner, and the final is right around the corner from that. It's insane. So,
Is the final May 30th?
the final is before the last. That last Monday kind of sucks. I have 2 finals on that last Monday, but we have the week before. But if it's May 30th, okay. I can't remember which day it is right now. It's on the syllabus. Yeah, that's too early for the final. The final.
It's on the 30th.
30th. Cool. So just to let you know.
So May 21st is the next test?
Yeah, the next test. It's the 21st.
7:15.
Yeah, I obviously don't set those times. We are, it's really, really nice. They finally built some time in between finals, because it sucked for students and teachers to try to rush to your next, you give your class time to finish and then rush to your next class. And then we get very territorial as teachers. Somebody's trying to come in, I'm like, my kids aren't done yet. My kids got to start. Get out of here. So it gets a little high tension. So they added some extra time in, which of course pushed the morning classes back. So yes, we get to start our final at 7:15 in the morning.
So there's no class on the 28th?
The last day of classes for us is the 23rd. And that's that Thursday.
Yes.
And then Friday, I think that Saturday officially is the last day of classes for everybody. Right? So then next Monday is a holiday, and then it starts into the finals on the next Tuesday. Yeah. So we have one more test left. We have the final exam left. Yeah, so it's getting down to the wire now. So with all that in mind, are there any questions from stuff we've covered recently? Yes.
6-2, how do you write
Oh yeah, okay. So if I had something that said 20 students is to 5 microscopes, as 4 students is to 1 microscope. How would you write that as a proportion? Yeah, 20 to 5, so 20 to 5 as 4 to 1, and of course that's a true statement, right? 20 divided by 5 is 4 over 1, if you want to be super technical. Yep. So proportion is defined to be the equality of 2 ratios. Cool. All right. Anything else from? Yeah. 6-3. Anyone in particular? Number 12? 12, yeah? All right. I got a second for that. This is page 427, number 12. Ramona Hatch. And they just had Meg and Bob. Ramona Hatch has enough money to put 6.9 gallons of gas in her Honda Civic Hybrid.
She can't find that last nickel to put 7 gallons.
Yeah, I know. Well, that's me. I remember driving home one time and I had nothing left in my account. And I'm shuffling through my car. Thank God I'm one of those people that throws change all over the place. I scrounge up enough change for, I think mine was 5.73 gallons. She's planning on driving home from college for the weekend, and her home is 200 miles away. So she can put 6.9 gallons of gas. Her home is 290 miles away. Should she make it home before she runs out of gas? So, and the thing that starts us off, the thing that somebody might have missed, is that in italics it tells you that the hybrid averages 627 miles on a 12.3 gallon tank. So she could put 6.9 gallons. It's bone dry. She just coasted into the gas station. She could put 6.9 gallons in that thing, and she wants to know if she can make it home. So how do you set up? So this is the one that they gave me. This is the ratio that I can set up from what they gave me. What can I put over there? There's almost too much information here in a way, but there's two different ways to really approach this problem. It doesn't seem like I have any unknowns, but I really do. This is how much gas she could put in, and this is how far she must go. So you could do either one, and that's nice that I got both of that from two different sides of the room. I like it. So you could do 290 over X and see how many gallons it would take to get home, or you could put X over 6.9 and see how far she can go on 6.9 gallons of gas. I mean, if this number comes out to be 240, well, she's walking the last 50. That sucks. That would be a long time. You know, or this way, if this comes out to be 5 gallons, then she's good to go because you can put 6.9 gallons in. I mean, that's so you got two different ways to do this. Whichever way you want to do. Is that one's kind of evil because it sounds like you don't have any unknowns. But these don't go together. This is how much she could put in there. This is how far she must go. So they each have their own X. I don't know how many miles this would get me. I don't know how many gallons this would take. So you can set it up either way. They both have to be equal to what the car can actually do. On 12.3 gallons, it could do 627 miles. Good, so that's the problem I would expect you to get a question on, because it sounds like they gave too much information on those, right? So, if we do it this way, what can I do?
627X.
Yeah, 627X equals something. Are you guys going to make a good
3567.
All right, 3567. I was almost there. And divided by 627. 5.68. So it would take this much gas to get home, and she can put that much gas in, so she will make it without having to push her car. Right? It's a hybrid, so it should be a little easier than otherwise. Kind of light. Just put it up on your shoulder and take it. Now, if you would have done it the other way, so this is one way you could do it here, and you can see from the answer, I know I'm good. She can put that much gas so she can cover how much gas she needs. Looking at it the other way, you can say, all right, I know how much gas I can put. I'm going to go ahead and fill the damn car up as far as I can with all the change I scrounged out of my car. But how far will that take me?
43.26.
Yeah, so you multiply, this will be 12 point, I'll do this.
426.3.
Do it again.
I mean, 432.6.3.
That's a neat way to say it, all right. All right, that sounds about right. And then you divide by 12.3. And you get what now?
Oh, shit.
Flush?
Uh, 351.97.
351.97?
Or 98, if you're on.
All right, I think we're good. Because she only had to go 290 miles, and on how much gas she can afford, she can actually go 351.97 miles. So she can even turn the AC on. Should be fun.
Wow.
I know, it's amazing. Cool. All right. Is that cool? That was one of the harder ones, I think, because they did give too much information. You have two different ways you can do it, but both ways have to agree. Right, how far I got to go, or how much gas I can actually put in. They should both agree in the end if you're going to make it home. Anything else from the homework? All right, so one of the main things to get from that, I think we're all starting to get this really well, is, I mean, these have got to match up. If you have miles over gallons, you better have miles over gallons on the other side. Otherwise, you get that weird, you need 11,000 gallons of paint to paint your wall. My God, the paint store will love you. Well, here comes that guy. Guy can't do a proportion. Here's your, got your order in, sir. Here you go. Keep them in business for a while. All right. So there's no other questions. We're going to get into more of chapter 7. That's the percentage chapter. All right. So you guys got all this here?
If not, you filmed it.
Yeah, exactly. So last time we did section 7.1. And let me do a real quick little review. So convert each of those to a decimal. So I know they have decimals in them, but they are certainly right now percentages. I want a true decimal number. That's expensive. So, I'm probably one of the teachers who gives the least mnemonic device type things, if you know what I'm talking about. There's very few. I mean, there's all kinds of songs and silly stuff you could do. And I'm not against that directly. Because I don't like it because it kind of takes away from the idea. It's more important to understand the idea than it is to have a cute little saying to remember how to do something. So, but here's one place where I use something possibly cute if you want to. Remember, percentage just means out of 100. So I know that anything I do is going to involve moving the decimal twice because it involves hundreds, right? So I already know the twice thing. It's always just the direction thing that's unclear. And the reason this works is because if it's 11.2%, that out of 100 hasn't been done yet. The division by 100 hasn't been done, so the number is going to get smaller. So if I am percentage now and I want to go to decimal, I go that way. Just put the letters DP down in alphabetical order, and the direction you have to move to get from any of the others, the direction you move the decimal. If you like that, use it. If you don't need it, that kicks ass. But there it is, if you need it. All right, so all of these are percentages, so I want to move the decimal back twice. The percentage number should always be bigger than the decimal number. So this has got to go back twice. 0.00004. Yeah. A little outer zero there. And then this guy once twice. So yeah, 1.289. So we don't let the number tell us what to do. We let the process tell us what to do. I don't care what number I put there. It's already really small. So what? It's got to get smaller. Too bad. Okay. Let's exciting. So if I want to go the other way around, if I want to convert from decimal to percent,
Go the other way.
go the other way. It's crazy. So if I have 4.27 or
A really cheesy way to remember the whole 2 decimal places too, if the 100 is confusing for some reason, is the decimal symbol. I mean, the percentage symbol has two dots.
zeros,
Like,
yeah, I used to do that. You take the number 100 and then just move it around. It makes a percentage symbol. Yeah. I don't know. That's not that works too.
it's just weird things.
Oh yeah.
The more obscure, the more easy to remember things.
All right. So how do you change each of those?
Move the decimal to the right.
Yeah. So now I'm going to go. Now I'm in decimal. I want to go to percent. So I want to move that way twice. So this becomes
427.
427%.
3.
Yep.
One.
Bam, bam. Just 0.3%.
11.42.
And once, twice, 11.14%. Percentages are completely made up by humans. I mean, they still work, but I can't use this number in a mathematical equation. I have to use the decimal number because that's the real number. This is something we made up to make it easier to look at these things. It's easier to look at 2.5% than it is to look at 0.025. Right? 2.5%, that's much easier to say and look at and think about. All right, it's not too bad, right? All right. So we're moving now into what I just said, actually. Equations with percentages in them. So we got this here. So, I've seen the weirdest stuff to do this kind of problem, and most of you have probably heard of like is over of. Have you ever heard that phrase before? Is over of. Anybody ever heard that before? All right, I'm not going to start with that method because I think that's not the best method. I'm going to let you use that method if you like, but I'm going to show you a method that's better. And I can officially say it's better because it has more general uses later. It reinforces the idea of translating into an equation. Plus the is over of thing, for the few of you who know it, sometimes it's hard to tell what the is number is and what the of number is. It depends on how they kind of say things. Whereas this one is much more direct. It just takes it right into an equation. So what the hell am I talking about? If I have a problem like this, what is 2.89% of 112? Now this one's almost too easy. You don't actually have to take this into an equation, but I just want to show you how it's set up. It's going to match what we would do anyway. What does that of mean in this case?
Multiplication.
Multiplication. So I know I'm going to multiply this times this. But here's what this looks like. This translates directly into math. This is one step away from math. What? What's that in math speak? X, 11, is equals 2.89%. How do I have to do that for math like it? Move the decimal.
To the left.
Yeah, once, twice back. You guys with me so far? Right. That's our convention. That's human percentages. Something we made up. Math says, give me the freaking real number, man. What the hell? Of, you told me, is times 112. That's the greatest equation to have when X is already solved. Right? And all you got to do is do that multiplication. So somebody help me out. What does it come out to be?
3.23.
3.23.
Or 3.4. I mean, sorry, 3.24.
So rounding it to the hundredths place. 3.24. Okay. So double check. Make sure you get the same thing. I like the way I do my counting. It's like in the movies. I'm going to hack into this. Alright. So the beautiful thing about this method is, no matter what I don't know, I just put an X in that place. It's always got the same format. So if I said this, if I said 40 is what percent of 103? the same format comes into play. 40, okay, math is cool. That 40 is
Equals.
what
Next.
percent of
Times 103.
times 103?
For 103, yeah.
And then you just solve for x. And then to solve for x, you just do what now? Divide by 103. What do you guys get?
38.8%.
So tell me what you get straight up. Point
0.388.
88. And then to make that into a percentage, once, twice over, 38.8%. Cool. So obviously, on these kind of problems, they'll tell you how far to round. Right. Is that let me give you guys a couple to try on your own. You guys try these two. Number 4 is freaky as hell, so don't freak out. Let me ask you, 2 is what percent of 2? 100%, right? If I had 2 last time, I got 2 this time, I got 100% of what I had. It's all still there. So what do you think 200% of 2 is? If 100% of 2 is 2, 200% of 2 is 4. So it took 200% just to get up to 4. I mean, it's going to take a crazy percent to get all the freaking way up to 300. So the number you get when you solve this is not a percent yet. It's a decimal. You actually have to make it bigger. So it's a little bit possibly counterintuitive until you realize that has got to be a huge percent of that, because 100% of 2 is 2. It's going to be a lot to get way the hell up to 300. Now, in a lot of situations, more than 100% makes no sense. But when I start talking about things like how much is the economy increased or decreased or so forth, it could certainly double, triple, or go down by that much, as we've seen, right? Okay, maybe. So how do you set up this first one? 38.
Equal.
Good? Yeah, back twice, so 0.014. That's probably going to be the step that's the hardest, because if it's not that specific kind of problem and you're not that comfortable with changing, you're going to forget what's going on right there. You might not even change it at all. And that's where you get freaky answers. But you've got to change percent to a decimal. So you can do the little thing here. It's got to go back twice. Bam. Of
X.
Good. Times X. Cool. You don't need the parentheses. I just put them in there. I'm not sure why. I just did. And then, of course, you just solve that for X. So you just have to do what? Yeah, divide by 0.014. Now, round that to the hundredths place. What do you get? If you need to. Right.
2700.
27.14. 27. 14.29.
You guys agree?
Oh, yeah.
Whoever's playing along? Right. Okay. And that makes sense. To be 1% of something, what's 1% of 100?
1.
1. Beautiful, right? Out of 100 is easy. 27% of 100 is 27. 1% of 100 is 1. So to be 38, and to be about 1% of that, it's got to be kind of a large number. So that kind of makes sense.
I thought the numbers seemed really big.
1% of this, and that's just to estimate this. 1% of this would move this thing back twice. It'd be 27. So 1.4% of this, it makes sense it'd be a little bigger. It'd be 38. Sounds about right. So if you think about taking 1% of something, moves the decimal back twice. Are we all cool with that? You all realize that? To take 1% of anything, it moves the decimal back twice. Then 38 would be 1% of 3,800. 1.4% of something, it can be a little smaller because I'm taking a bigger chunk of it. Does that at all make sense? This is that background thing. The better you can estimate something, the better you can catch something that doesn't make sense. You guys semi with me? So it's one thing, that's the worst thing to me is when I have somebody in my 110 class who tells me like I want to build a garden in my backyard and they say it's got to be 8,000 feet by, and I'm like, my backyard is probably not that, you got to have some kind of feel for what or it's even worse when they say it's got to be negative 18 feet by, okay, so stop. Just think about what's going on. But you're right, that seems like it might be weird, but you got to think about it. It actually kind of makes sense. What about this guy? How'd this get set up? 300?
Equal
Times 2x. You can just write 2x, but I'm just going to do like straight, exactly how it's written. And then, of course, you just
divided by 2.
Divide by 2. X is 150, but to make it into a percent,
To the right.
yeah, I got to move it once, twice. So it's 15,000%. So if my company made $2,000 last year, and this year they made $300,000, that is a 15,000% increase in profit. It's pretty good. That almost takes me back to what it was before the recession. All right, yeah. Yes.
Can you just divide the number by the percent and then just move the decimal twice for your answer?
Oh, for like this one here?
For any of them.
Well, here I don't know what the percent is.
Oh, I see.
Yeah, so you're right. On each of these, there is a possible shortcut. You might not have to set up the equation if you kind of know when to divide, when to multiply. Are you guys with me? But setting it up into an equation will always work. You'll end up doing the operation you should do. But some of you guys might not even need to set the equation up. You kind of already know when to divide, when to multiply. That's awesome. The more you know, the less you got to do. As always. The less comfortable you are, the more you should probably do. How are we feeling about this stuff here? All right. Let's do a couple more. Which part is giving us some trouble?
I just want to know why sometimes you move the decimal 3 times or 2 times.
I only ever move it twice when I'm talking about percentages.
Only twice.
Always just twice.
When I convert it to, when it's a number and I convert it to percent, right? Only twice.
Only twice.
Oh.
I love it.
Left
So
and
please,
right.
if you ever see me moving it 3 times and we're doing percentages and decimals, dear God, stop me and say, Jeff, dude, know what you're teaching. I'm like, oh shit. But yeah, I don't. Do you know where that might have happened? Did that happen?
I think the one before. I'm not sure. Maybe it's just.
That's okay. Sometimes it looks like I moved it more than I actually did because it ends up.
Yeah, there's like.
And of course, sometimes with that extra 0 in front, I mean, sometimes we take that 0 and we think it's part of what happened, and it's not really. Yeah. But you're right. If I did, you should definitely not. It's only twice. Cool. So let's do one that's a little bit. Let's one step away from this. Last year, 427 people went to a concert. this year, 480 people went. What was the percent increase? So let me take a step back for a second. Let me ask you a very, very basic percent problem. If there are 40 people in this room, and I don't know, 10 of you are watching the NBA finals, watching the NBA playoffs.
Mm-hmm.
What percentage of the people in this room are watching the NBA playoffs?
25.
Yeah. So if there's 40 people, and 10 are doing whatever, then it'll be 10 out of 40 to figure out the percentage doing this thing, right? The percentage people watching the NBA playoffs is how many are watching the playoffs divided by the total. The percentage of women in this room is how many women divided by the total. So the percent increase is, I got to first figure out what the increase is and divide it by the total of what it was. So how much did it actually increase by? What is this number I need to use on the top? No. How much did it increase by? I can see it, right? How much did it go up by?
$53.
Putting the 7 in the wrong place. Yeah, 53. So then it'll be, to figure out the percent increase then, just like percent women was women divided by total. Percent NBA watching people were NBA watching people divided by the total. Percent increase is increase. Now here's where it gets a little freaky. Divided by the total, it would be this. What increased? What amount increased? This increased to this. So it was 53 out of this that went up to this. So it's always over the original. So 53 divided by 427. Now that's the direct way to do this. Let me kind of show you how it would set up over there. You could say, what percent of 427 is 53? You could put it in that question format. So if you can make something into that format, you can make it into an equation easy. But this is one place where I would probably not even use the equation. You could just do it directly. Here you'd say, I don't know, 427 is 53, and now you can just divide and you get exactly the same thing right there. What is 53 divided by 427?
0.124.
So it's about 12.4%, right? Moving that over twice. So about a 12.4% increase. So why did it make sense that we put 427 down there and not 480? Because what would you take 12.4% of to check it? Of 427. Take 427, 12.4% of it, and add it to see if we come out to be 480. It should come out to be close, because I think this is probably rounded.
It's 12.41.
12.41 exactly?
No.
Or even that? Okay, cool. Gotcha. All right, maybe.
What's the question?
If you wanted to check it, you would take 12.4% of 427. That's why it makes sense that that's what this number's on the bottom. That's the number that's kind of telling me what's going on. It's where it started. So it's the thing that changed to this. So it's the thing I base my question off of, 427, the original amount. Maybe. So it's just like if I was making $10 an hour and now I'm making $9 an hour, that's a 10% decrease off the $10 I was making. It's always off the original. It's always based on the original. Okay, cool. Maybe. So that's the same kind of problem. You could try to reword it into this format if you wanted to, but very often you can just kind of go straight to the answer, straight to the setup for the answer. So what about this one? Let me try another one that's not quite like that. This is a little bit more straightforward. Everyone lost 4.2% of their savings at gross point last year. If I had $2,800 in savings, how much did I lose? What do you think?
$117.6.
Yeah, so I could write this in another format. I could say, what is 4.2% of 2,800, the savings, right? And I can set that up into an equation. Again, a lot of you guys might not need to. You should know you need to take 4.2% of 2,800. You just do that directly. But it's kind of nice to think about it. If I can just reword this question like this, I can make it directly into an equation. So what is, how does this change here, 4.2%?
0.04.
Yeah, one's twice back, 0.042 of 2,800. And now you just multiply those out.
117.6.
117.6. That's how much money I would have lost if I would have had that much money to begin with. All right, cool. It seems like nowadays just percentages are not as well understood as they used to be for some reason. We don't have a more innate, intuitive understanding of them as much as we used to. The word "of," people forgot that means multiply. I think they're just not harping on that as much in high school. I don't know. Percentages are sort of a mystery to a lot of people. Hopefully I've just demystified a little bit of it. So I'm officially, and I know a few of you guys have already done this, which means you've already got extra credit, but I'm officially making 7.3 extra credit. Look at that interest workup. So section 7.3, homework, is extra credit. If you don't want to do it, if you've never seen that method and you don't want to do it, I actually believe it's not necessary to know that method. If you like that method and you want to do it, awesome, do it. I'm not going to make it do.
You say 7.3?
7.3, yeah. So that's the proportion method for this. That's the is over of thing. Is that about 3 of you have heard of it? Or at least wanted to admit that you've heard of it?
Do you want us to move on to our problem?
Do it again, sorry. The homework assignment from 7.3 that's already on the homework sheet, that's extra credit now. Yeah, so if you don't want to do that, if you're behind in homework, this will help you catch up a little bit.
If we already did it.
If you already did it, you already got extra credit if you got enough of it right. So we got one last section in chapter 7. And this is what I would call, we basically just did a few, actually I just did section 7 forward away. This is the word problems, but they're not really word problems. They're the ones you can try to reset up into what percent of what is what, that kind of thing. So look at page 494. Let me give you a couple to try real quick. Number 8. 14. And 18. Oh, yeah.
I could put them on the board so they'll be on the video. I can put them on the board so they'll be on the video. So when you're done with these, talk about these and then I'll do those. Why not? Because some of them are ones I expect the questions on. I haven't gotten questions yet, so we'll do them. Okay. So again, I'm going to kind of do it in the way I'm going to try to write it in that sentence, in that question. But a lot of you guys might be able to just run straight to the work you got to do. So here, if 8% of all the films are rated PG and there were 725 rated films, what is 8% of 725 then? That's really what my question is. 8% of all films were PG, 725 films were rated. So 8% of 725 is what? That's my question. So X is 0.08 times 725. 58? 58? Okay. So 58 films are rated PG. 725 films, damn. I have no idea. There's always more films out there, just like there's more political parties than you'll ever know. Number 14. In 2001, there were 37,900,000 something about dogs. I can't remember now. That's on my head. Dog owners. Is that right? It increased by 13.5%. Many of them probably should not own dogs, but oh well. So how many own dogs now? So this is kind of a two-step problem, because first you're going to figure out how much it went up by, and then you got to actually add that on. So if I wanted to put it as a question, I'd say, again, I'd say what is 13.5% of 37,900,000? So now I can just do that multiplication. 0.135, take this back once, twice, change it to a decimal. Of is times 37,900,000. And whatever that is. 216,500. Take your word for it.
Then you just add that to 2000.
So that's how much it increased by. So that's step one. So there's a 5 million increase. So how many actual dog owners are there in 2007? I have to add that on top of 37,900,000.
43 million.
Yeah.
16,500.
That sounds about right. Dog owners. Is that cool?
And then number 18. Number 18 is the classic percentage problem. And it's an example of something where it seems to me people have a harder and harder problem with this, because now the science teachers have asked me to include this kind of problem in a little workshop I do for science students. Because they said, less and less people know this, Jeff, help me, dear God. And to me, it's just such a basic thing that I just think they're not teaching it as hard as they used to or whatever. How to get a percentage out of something. If I have 3 people out of 20, well, it's 3 over 20. And then you make it into a decimal, make it into a percent. Right? But it's just kind of getting lost. So here I got 28 out of the 115. That already sets itself up into a fraction. 28 out of the 115. And what do you get when you divide that? And your calculator probably not like that. Jelly. Do it again. 0.23. 2435, so 24.35% roughly. Does that sound all right? I'm a trusting fool. I'm trusting those numbers are right. That's what I do.
Is it right there? The why is the of division, not multiplication?
Say again.
Why is of division and not multiplication?
I like it because it's really out of. Yeah. So it's not. So I was really careful when I said that of is multiplication. When it's a percentage of something or a fraction of something, that means multiply. So of doesn't mean multiply any time you see it. Right? Of means multiply when I'm talking about percentages of something or fractional parts of something. This is 28 out of the 115, so that's actually truly a fraction. Out of. Cool. All right. Cool. All right. So any questions on that type of problem? Yes. Oh, here?
Yeah.
Oh, just multiply these. Oh, no, this kind of problem, I'd let you do that in the calculator. Right. I have a whole section where you won't be able to use your calculator, but when I give you the word problems and the equations, you can go ahead and use your calculator, because then I'm more grading you on, can you set this up correctly? Can you do the steps correctly? I've already graded you on, can you do this by hand correctly? Right. Is that cool? So you're cool with the 5 million? So that was the increase from 2001. So how many in 2007 then? I have to add this to this. That's why I wrote that underneath. I can add it up. Yeah, cool. So anytime they talk about an increase or decrease, it's probably going to be a 2-step problem. Because you got to first figure out the increase or the decrease, and then you have to apply that. So if I said a shirt was 10% off and it cost $30, you don't say, yay, now it's $3. No, it's $3 you take off. Sorry, buddy. All right. In Math 90 and Math 103, you'll be doing what I consider to be true word problems. I don't consider these to be true word problems. They're just one step away from computation. True word problems would be a hat is 20% off. So the sale price is $13.48. How much was it originally? Now that involves more work. That's setting up a true equation where you got to solve it. It's not quite as straightforward as these problems. These are a little bit better. They're just one step away from multiplying or dividing. Is that cool? All right. So a little preview of the next thing, and then we're out early again. This is all I have. We're almost out of things to talk about, if you've noticed, right? Which is fine. This is fine. There's nothing wrong. Because again, the main thing I want you guys to get out of this class is to feel comfortable solving a lot of different kinds of equations and have some exposure to word problem kind of things. Because all the extra stuff we've done, talking about fractions and decimals and so forth, that's the computational stuff. That's been throughout the whole thing. So I should have been kind of building up. More of us should know now what 7 times 9 is, hopefully. Now, as you've seen something like that over and over, it should be in the brain a little bit better. So a little preview of the next chapter.
And normally, when I ask people to rank what they hate about math, I mean, number one, obviously, is word problems. But number two, for very many people, is graphic. And that's what Chapter 8 is all about. Oh, yeah. I hear some people agreeing with me.
Like on a number line?
More than that. Graphing in 2 dimensions.
Oh, right.
Now in fabulous 2D. So, I mean, what you're talking about, if I had, if I wanted to graph the point x equals 4 on a number line, I have to leave room for it now. Bam, just put a point on that, whoop-de-doo, right? Where things get more interesting, and of course you've all hopefully heard, you know, graphing on coordinate system is just like our latitude, longitude, so you can find yourself, and that's a standard thing, but it's actually true. It's a way of locating something. So if I want to locate that point, and I'm here, I've got to go over this much and up so much to get there, right? If I'm at my house and I want to go to my friend's house, I got to go over 4 blocks and up 7 blocks, and I can actually identify that as a point. My house would be 0, 0. My house would be the origin, where I begin. And then how much do I have to move over and up? So past this class, you would actually move off the frickin' board. 3D! You can go over, up, and out and find locations anywhere in space. Holy shit. And of course, Math 285, you talk about ADD, but let's not go there. Let's not talk about that. 80 dimensions. Let's just start with just one quick little example. So we have this number line already established that we've used several times throughout the semester. When I add in another direction of motion, so this really only gets me I can move left and right. That's okay. But then I miss a lot of the world. So I want to be able to move, you know, instead of just east and west, I want to be able to move north and south. And of course, the next level would be able to jump into the air. Let's not do it. Dig into the ground. So I'm going to add in here another direction of motion. In a perfect world, it would be straight. That's all right. So I've got my same scale kind of idea here. But now the same idea applies here. But this one just goes up and down. So instead of just being able to find the number 3, the number negative 2.5, and whatever, I can now find points. It's a little bit more, I can now do an area instead of just a length. I can now find something on the entire board instead of just, it's got to be on my number line to find it. So this point here, how would you tell somebody if they start here? This is the origin. This is the point 0, 0.
X2 and then Y.
Yeah, I'd have to go from here, I'd have to move twice over and then 4 times up. So this is officially the point 2, 4, X, Y. Alphabetical order, thank God.
Or you just started
So where would the point negative 1, 3?
We gotta go over
Yeah,
one.
I gotta go back 1. That's the first thing tells me how far to move left and right.
And then up 3.
And then up 3. And then I can find my point there. So you can see how this is exactly like the latitude, longitude. If any of you guys, anybody ever heard of GPS caching? You ever done that? I had a friend who was really deep into it, and I actually found one of the little capsule things. So it's this really neat thing where they have, you can download locations of these little things, and you unroll it, and you put your name on there saying that you found it. And some of them are actually, you have to dive to get to them. You've heard of that?
Are they like to hide it somewhere?
Yes, they hide it somewhere. Your GPS, the better your GPS is, the closer you can get to it. You got a suck-ass GPS, you'll be doing a lot of walking around. I didn't really get that much into it, but I found one thing. And that was enough for me, I think. But this is the same idea. I want to find a location on basically the surface of the Earth we can consider to be flat, even though we know if you go far enough it's round. But for me, it looks freaking flat. So we just lay on top of it this grid, and if I want to find somebody, somebody's calling me from a boat, we need some help, where are you? Well, we're here and here. Okay, good, I can get to you now. I know how to get to you. Right, this is just a way of locating things. That's why it makes sense. The minute I send satellites into space, I need to have some way of finding them up here.
Move over here, move over there, and then go up from the earth. So, okay, then that's where you are. Yay. But we're not going to talk about that in this class. We're going to keep it all on board. So that's the major preview. We'll be graphing points, and then we'll be graphing equations. Yay.
Sweet. Early days.
That is, it's true.